Hi, everybody, and welcome back to another math lesson. Today we're going to talk about scientific notation. You may have heard about this or seen it in a science textbook, or if you've ever accidentally hit a wrong number on your calculator. You've probably seen it, but you didn't even realize what it was. Today we're going to focus on scientific notation where there are positive exponents, but before we get down that road, let's talk about what is scientific notation. It's used to express very, very big numbers and very, very, very tiny numbers. Very large and very small. And I'm going to use hashtag for numbers. So scientific notation is how we write the distance from Earth to Pluto or Earth to Mars, or because we can't use miles and we can't use kilometers because, well, it's a lot further than that. So when we talk about like millions, billions, trillions, and bigger, it's easier to write it if it's just a little number. And so when we deal with, today, positive numbers, we're going to focus on the very large numbers. So with positive exponents, we deal with large numbers. So to back this up a little bit, to write scientific notation, it deals with the idea of powers of 10. So 5 times 10 is 50. 5 times 100 would be 500. 5 times 1,000 would be 5,000. And as those numbers get bigger and bigger and bigger and bigger, all the numbers get longer and longer and longer and longer. There's a shorter way to write these numbers. So 5 times 10 is 50. If I add an exponent of 1 to 10, it's still 10. Now it's in scientific notation. So 5 times 100 is 500. So the way to write this in scientific notation would be to say 5 times 10 to the second, because 10 times 10 is 100. So this is going to be 10 times 10 times 10. So 3 times. So this is going to be 5 times 10 to the third. What kind of relationship do you see between these numbers over here in scientific notation, and standard notation? What is the relationship that you're seeing between these two representations? One thing you may have noticed is that the exponent corresponds with how many zeros there are on this 10. That's how that kind of works. When you start to look at those patterns, the exponent corresponds with the zeros, and that's kind of a shortcut trick, but hopefully you understand how that's happening. 10 times 10 times 10 is 1,000, 3 zeros, exponent of 3. And so when I have these positive exponents, I end up with bigger and bigger and bigger numbers. So if I had 10, let's say 10 to the 7th power, how many zeros would there be for 10 to the 7th power? There'd be 7 zeros. So we would write 1, and then 1, 2, 3, 4, 5, 6, and 7. Now, that's a big number. So numbers that are even bigger than that, we don't want to waste the space. Waste the space might be harsh. I don't want to use up the space. It takes a lot of time to write out all these big, 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 big numbers. So we write them in scientific notation because it represents that number, and we get an idea of what that number is in a smaller amount of space. If you had a number that had like 37 digits in it, it starts to lose its meaning. So we write it in scientific notation so that we can still understand it without ridiculousness. Okay, so to work with this, we have to be able to take a number and put it into scientific notation, take a number in scientific notation, and move it out into standard notation. So let's say I have a really big number. If I have the number, bear with me here, 32850, 1, 2, 3, 1, 2, 3, and 1, 2, 3. And I spaced those out purposely so that it's easier to count. So this is hundreds, millions, trillions, billions. Off the top of my head, I don't know what comes after trillions, billions. Really don't know. Okay, so the first thing I need to do is I need to take my decimal. Here's the decimal. This is my original decimal. And I need to move that decimal until there's only one digit in front of it. So step one, I'm going to move decimal to the left until there's only one digit in front of the decimal. Until there is only one digit, maybe make that one digit in front. So what is the first digit? The furthest left digit. What is that digit in this number? 3. So this is where I want to move my decimal to. So I want the decimal to, I want it to be 3.2. Use a different color. 3.2. That's where I want it to end up. So step 2 is to count how many digits did you jump over. So step 2, count the digits you jumped over. It's not a very mathematical term, but so we started here and we went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 numbers to get from the original decimal until the new placement of the decimal. So step 3 is to kind of put those two steps together. So step 3 is to write your new number and you're going to drop all the extra zeros. Yes, just S. I don't know. Okay, so you're going to drop the zeros. This becomes your base. So I'm going to have 3.285. 3285, yeah. Okay. Then you're going to write times 10. And then your exponent is your number of spaces. From step 2. So my new number is 3.285 times 10 to the 13th. Because if I do 10 times 10 times 10 times 13 times, I'm going to have a 1 with 13 zeros. And this number times a 1 with 13 zeros equals this number up here. So let's take a number out of scientific notation. So we're going to work the steps backwards. If I have 1.23 times 10 to the 5th. So going backwards, I know that this exponent is the number of spaces I moved in step 2. So writing the number, I know it's 1, 2, 3. So 1, 2, 3. And now I need to go backwards. If I went left, the opposite of left is to go right. So if I start here, this is my starting point, I need to move 5 spaces to the right. So I'm going to start here and I'm going to go 1, 2, 3, 4, 5. Put a decimal. And where I dropped the zeros, I'm going to add zeros. So to go from scientific notation to standard notation, I take the digit. This is how many spaces I move the decimal to the right. So my decimal here, move it to the right this time. Because remember, when it was a big number, like up here, I'm dealing with positive exponents because that's how many digits there are, or how many zeros there are. I know that this can be kind of confusing because it seems really easy, but then once you start practicing, you might get confused. If you need any help, shoot me a question on Canvas. You can send me a snapshot of a question that you have. We can check it together. I'm available for Zoom tutorings if you ever need me. Y'all have my sign-up link. Other than that, I'm going to let you practice because the best way to get better at this is to just practice, practice, practice. All right. I will see you guys tomorrow. Hang in there. Y'all are doing a great job.